Hello everyone. So guys, I'm Rahul Kaushik and I welcome you all on Unacademy JEE English. Yes guys, Unacademy JEE English. And today in the series of rapid revision, I'm here with a new session guys. And today we are going to cover ionization energy and electrochemistry in rapid revision series. And it's very cold here. So guys, are you ready for today's class? Yes. Are you ready guys? So let's start today's session. But before I start today's class, yes, let me tell you something about myself. Just a minute. Let me arrange this mic. So, guys, I'm Rahul Kaushik and I worked in Bansa Classes Kota for continuous 10 years, guys. And during my tenure there, I was head of department. Yes, I was head of department and I even mentored 2000 plus IITs. And after that, guys, I'm here on an academy, this fantastic platform. So this JEE English channel, actually now you all know that the purpose of this channel, yes, to the purpose of this channel is to spread education in each and every corner of India, whether the student understand Hindi or not, because 99.9% channels in India which are helping in preparation of IIT JEE or NEET UG or any other competitive examination, they are in Hindi. So this is a initiative by an academy, and yes, we are spreading free of cost education, guys, here. So I think you know about all of you know about it. And after this, yes, you can. Now I will tell you, if you are interested in joining an Academy's Plus subscription, then how you can join us. We are also there on the Telegram app, and on the Telegram, yes, on the Telegram you can join us. JEE English. Yes, this is our channel name. JEE underscore English actually. Just interchange it. So now I will tell you what are those simple steps. Using those steps, you can subscribe to an academy. Now, guys, the step number one: just go to Play Store or App Store and download an Academy's Learning app. Once you have downloaded it, install it. And after installing it, you will be directed to this page. And on this page, you have to click on the plus. So once you are clicking on the plus, then you have to choose. Then you have to choose IIT JEE and this IIT JEE as your goal. Once you have chosen IIT JEE as your goal, guys, then just hit the subscription button. And once you are hitting the subscription button, then you will be directed to this page. So on this page, just remember this code Rahul came, because if you are applying this code, you have to pay 34,000 for 1 year and you have to pay 50,000 for 2 years. Okay, guys, and let me tell you the exact fee structure. Yes, without this code Rahul came, for 1 year you have to pay 38,000, for 2 year you have to pay 56,000. But if you are using this code Rahul Kim, then the fee structure will be, for 1 year you have to pay 34,000, for 2 year you have to pay 50,000. Okay, guys, got it? So this will be your fee structure if you are using this code Rahul Kim. So guys, remember this code. It will help you in getting 10% off. Got it? Got it, guys? So now let's start. So what are the advantages of joining Plus? Can you tell me what are the advantages of joining Plus? Anyone? So guys, now I will tell you the advantages of joining the Plus program. So point number one, on the Plus, your course would be structured. And what do you mean by structured? Structured means every fourth class will be your doubt clearing session. Every fourth class. That's important. Every fourth session will be doubt clearing session, and not just doubt clearing session, and you will get regular modules and DPPs. So after every class you will be getting some homework in form of DPPs, in form of module, and after that you will have live quizzes there. And once your topic is over, guys, once your topic is over, then after completion of topic you will have mega quiz. You will have mega quiz. So these are all the things which you are going to get once you are part of an academy subscription plan. Okay, and not just that. Now let me tell you one more thing. Whenever you are preparing for any competitive examination, any competitive, so you need to have a very good paper temperament, and in order to develop paper temperament, you should join a test series. So you will have access to that iconic test series, guys. That iconic test series conducted by an academy, where you can take topic test, you can take part test, you can take full test, each and everything. And after this, you will have access to not just my video lecture and content, but the video lecture and content of all the educators who are teaching over there. Right? Got it? So any doubts? Any doubt, please let me know. No doubts? So now let's start. Now let's start today's class. But before I start today's class, let me tell you what we did in the previous class. So in the previous class, we did atomic radius, right? And types of atomic radius. So how many types of atomic radius was there? So whatever we discussed like covalent radius, and after covalent radius, metallic radius. Not just metallic radius, we also call as crystal radius, and after that we did van der Waal radius. So three kind of radius were there, and I even told you why do we need all these three kind, because every element or atom of every element cannot form all type of bond. So if there is covalent bonding, then we calculate covalent radius. If there is metallic bonding, then we calculate metallic radius. And if there is van der Waal bonding or van der Waal attractions, then we calculate van der Waal radius. Got it? So inert pair effect we covered in the previous class. Again, I will tell you what is this inert pair. So guys, in this case we have 14F element and a 10D element. So overall there are 24 elements before helium and Pb. So I can say if 24 elements are there, so along with 24 electron, 24 protons were also added. So these 24 protons, so the general configuration for this helium, what it would be? Let me tell you. General configuration for helium will be, yes, it would be 6s2 and 6p1, and before that you will be having 4f14 and 5d10. So this is the general configuration of helium after xenon. So what will happen now, due to these 24 electron, yes, they will have very poor shielding effect. They will have very poor shielding effect, right? Shielding effect, how will you feel the shielding effect? So shielding effect, you can consider it as a repulsion, right? So this is nucleus, and here we have electrons. So outermost shell we have 3 electrons, 1 2 and 3. So what I'm saying, when these 24 electrons are added inside, so along with them 24 protons were also added. So now what will happen, these protons will attract all the electrons, but the repulsion effect of these 24 electron is very less. As a result, net force of attraction on outer electron will increase. So what will happen, after losing one electron, these 6s2 electron become inert, right? So net force of attraction on them will increase, and due to that increase in net effective force, what will happen? Due to that increase in net effective force, what will happen? Tell me. Two electrons will become inert and they will no more participate in the chemical bonding, right? So we call it inert pair effect. We call it inert pair effect, and as a consequence of inert pair effect, what happens? Tl plus 1 is become more stable than Tl3 plus. Pb2 plus become more stable than Pb4 plus. Why? Because it is having 6s2, 6p2. So after losing 2 electrons, these 2 electrons of S become inert. Why? Because net force of attraction on these 2 electrons increases and increases to a very large extent. So they become inert and we call it inert pair effect. So due to inert pair effect, low oxidation states become more stable. Got it? Low oxidation states become more stable. Right? Now let's discuss about the radius of ions. So if I talk about the cation or if I talk about the anion, so let's discuss the case of, just a minute. Suppose if I'm taking lithium and after losing one electron it becomes lithium 1 plus. Electron and proton on this lithium will be 3 and 3. Got it? In this case, after losing one electron, it will have 2 electron and 3 proton. Now what will happen? We have 3 proton, we have 3 proton, and both of these, all these 3 proton will have positive charge. Here I am having this and one more electron. Here I am having 2 electrons. So what is going on, guys, here? These 3 protons, these 3 protons are attracting it. These 3 protons are attracting 2 electrons only. So can you tell me where the attraction will be more? In this case, 3 protons are attracting 2 electrons, so attraction will be increased, and as you can see here, the one shell is missing because one electron from this is removed. So size of cation will be smaller than the size of neutral atom. Size of cation will be smaller than the size of neutral atom. Got it? And now you know the reason. Now you know the reason. So I can say in general radius of A will be greater than radius of A plus. Size of cation will always be smaller. Got it? So why it will be smaller? Now you know the reason. So let's discuss this point. Because number of proton are fixed and because one electron is being removed, so size will decrease. Right? Size of cation will be smaller than the size of neutral atom from which it has been formed. So radius of A will be greater than A plus. Why? Generally the force of attraction will increase and size will shrink. Got it? And what about the anion? So in case of anion, guys, let's do it quickly. In case of anion, we have fluorine, we have one more fluorine, and this fluorine is having 9 electron and 9 proton. So once it gain one electron, so I will be getting 10 electron and 9 proton. So these 10 electron, there will be high repulsions. Why there will be repulsions? Because now we have 10 electron in a very small region. Now we have 10 electrons in a very small region. So due to it we have repulsions over here. Yes, right? And initially 9 proton were attracting 9 electron and now 9 proton are attracting 10 electron. So can you tell me where the net force of attraction will be more? In which case net force of attraction will be more? Yes, in this case, because it is like tug of war. On one side we have 9 proton, one side we have 9 electron, one side we have 9 proton and 10 electron. So now they are stronger. Now this is relatively stronger. So in this case the size of an ion will be greater than the size of neutral atom. So I can say the size order will be like this. Got it? Anion will be larger than the neutral and cation will be smaller than the neutral atom. Got it? cation will be smaller than the neutral atom. Any doubt? So let's move ahead now. So if I talk about cations, Fe plus, Fe2 plus, Fe3 plus. So what is going on here? So number of electron here 25, 24, 23 and number of proton are 26. So in which case, tell me in which case net attraction will be more? In which case net attraction will be more? 26 proton attracting 23 or 26 proton attracting 25? In which case it will be more? Yes. In this case the attraction will be maximum, so the size will be minimum. So now I can say as magnitude of positive charge increases, size decreases. As magnitude of positive charge increases, size decreases. Similarly, if I talk about the anions, suppose I am taking n minus 1, n minus 2 and n minus 3. Now what will happen? Can you tell me now? What will happen? Anyone? So in this case, if I consider number of electron and proton, 7, 8, 7, and electron are 8, 9 and 10. So most effective attraction will be here. 7 proton are pulling 8 electron, 7 proton are pulling 10. So attraction will be maximum here. If attraction is maximum, so it will be the smallest and it will be the largest. So the order will be this. The radius order will be this. Got it? So as magnitude of negative charge increases, size also increases. Note it down. As magnitude of negative charge increases, size also increases. Got it? Yes, Manish, you should solve the complete exercise. 1, 2, 3, 4 and 5, everything. Right? So now let's talk about the isoelectronic species. So when I'm talking about the isoelectronic species, what is this isoelectronic species? Let me take one example of it. Suppose if I'm taking carbon, nitrogen, chlorine, right? 4 minus, minus 1, plus 3. So in all these scenarios, if you count number of electron and proton, what will you get? Can you tell me guys, what will you get? Anyone? So number of proton are 6, 7, 8, 9, 11, 12 and 13. Number of electron are same. Got it? So can you tell me in which case the force of attraction will be maximum? Yes, in which case force of attraction will be maximum? Is there anyone who can tell me? In which case force of attraction will be maximum? Anyone? So now I will tell you. Here 13 proton are attracting 10 electron. Here 6 proton are attracting 10. So 13 will attract them more strongly. No, the attraction will be maximum here. The attraction will be maximum here. It is like 13 proton and on one side we have 10 electron. Here we have 6 proton and on one side we have 10 electron. So which force will be stronger? This is tug of war. So now tell me in which case attraction will be maximum? Tell me. So attraction will be maximum in this case, the size will be minimum. So I will say the order of size. The order of size will be this. And guys, I call them isoelectronic species. Why I call them isoelectronic? So these are Isoelectronic species. So for isoelectronic species, yes, size is this. So now you can say as E by P ratio increases, size increases. Got it? So E by P ratio will be maximum here and minimum here. Got it? Yes. So you can make it a rule. You can make it a rule. Okay, Om. Got it? Tell me now. Any doubt? Any doubt, guys, you have? Okay. Now let's move. So can you tell me the smallest cation in periodic table and smallest anion in periodic table? Can you tell me that? Anyone? Smallest cation and smallest anion. Yes. Is there anyone who can tell me that? Can you tell me the smallest cation and smallest anion in the periodic table? Yes. Note it down. The smallest cation, it is H plus, and smallest anion in periodic table. Yes. What it will be? It will be F minus, not H minus in periodic table. Note it down. Got it? Any doubt? Any doubt, guys? Yes, tell me. So now this is done. So ionic radii you can compare. Ionic radii you can compare, and how you can compare? Can you tell me? Now I will discuss the ionic radii. Yes. Li plus Le ना की रब से फरियाद. But we don't study this because only some microgram of francium is found in the nature. And then we have, got it? So is there anyone who can tell me the order of this size? What will be the order? So as we move down the group, this radii will increase. This will increase. Not an issue. But here we have exception. Yes, out of lithium. Can you tell me that out of lithium and beryllium 2 Mg2 plus, which one will be larger? Yes, out of lithium and Mg2 plus, which one is larger? Because lithium belongs to second period and Mg belong to third. So ideally magnesium 2 plus should be larger. Got it? But lithium is larger. So how will you remember it? So now I will tell you guys the way to remember it. This problem have been asked in IIT JEE. and you can remember it like this way. Got it? So here I can say Na plus is larger than Ca2 plus, K plus is larger than Sr2 plus, rubidium plus is larger than Ba2 plus. Remember this data. I will not ask each and everything, but this data has been asked in JEE Advanced. I think it was asked in 1998. Yes, almost more than 20 years back this problem was asked. So I'm telling you to remember it, to remember only this thing, right? So yes, this is the actual data. If you want to take a screenshot, you can take it. Yes, from here if you compare 0 0.9, 0 0.85. So Li plus is bigger than this, Na plus is bigger than this, K plus is bigger than this, Rubidium plus is bigger than this. Got it? Any doubt? No doubt now? Tell me if you still have any doubt. And down the group, size keep on increasing. So remember this table like this way. In case of ions, yes, most of the students face issues. Got it? Now let's discuss the penetration effect. So what do you mean by penetration effect? So now I will tell you the penetration effect. Penetration effect. So if I'm talking about the penetration effect, suppose we have S. It is a spherical. Then we have P. It is dumbbell. Okay guys. And then we have D. It is double dumbbell. I'm just making the representative shapes, right? So this is D. Here I want to tell you one point, and that point is that S electrons are maximum close to nucleus. At the center we have nucleus. This is the nucleus, right? So at the center we have nucleus, and if we have that nucleus, how that nucleus will help? Now I will tell you. The S electrons spend most of their time close to the nucleus, but if you observe in case of D, yes, electrons spend most of their time away from the nucleus, even in P, but in D they are too far away. In F they will be much more far away. So the S electron, if an electron is present in the S orbital, then it will experience more attraction force as compared to P and D. So I will say that S electron will have more penetration effect, and those electrons are more penetrating towards the nucleus. Those electrons are more penetrating towards the nucleus. Got it? So the penetration order will be NS, ND, and LF. Got it? So this will be the penetration effect. So now what is penetration effect? Now you can read it again and it will be clear. As S electron penetrates closer to the nucleus and therefore more tightly held than p electron, because they are more tightly held than p electron, right? Similarly, a p orbital electron is more tightly held than a d orbital electron, and a d orbital is more tightly held than a f orbital electron. So I can say the order of penetration will be this. Generally, due to spherical shell, s electrons spend their most of time close to nucleus as compared to p, d, and f, and due to their double dumbbell and diffuse shapes, so due to their shapes they have very poor shielding effect as well as very poor penetration effect. Remember it. Means they are poor in all sense. They are poor in repulsion. They are poor in attraction towards the nucleus. Got it? Any doubt? So when I'm telling you this, so penetration effect is clear. Now you know that NS, NB, and D, NF. So you can compare CP with 3D, but not CP with 4D. Got it? That's why I'm writing here N. So shell number should be same. Shell number should be same. Got it? Tell me now. Any doubt? Any doubt if you guys have? No doubt. So let's move now. So if I talk about the ionization energy, what do you mean by ionization energy? So if we have a gaseous atom and I want to remove an electron, then what will I have to do? Suppose I am taking sodium or lithium. So if it is lithium, it is having 3 electron and 3 proton. All these electrons are attracted. All these electrons are attracted towards nucleus. And if these are attracted towards nucleus, what will happen? I want to remove it. So I have to work against this attraction. And when I am going to work against this attraction, what will happen? I will be getting this. So now I will be having 2 electron and 3 proton and 1 electron will be removed. So because I'm working against the attraction, so what will happen? I have to provide energy. And in order to provide energy, I will call this energy as ionization energy. So what is ionization energy? So first of all, this is amount of energy required to remove most loosely bound electron from an isolated gaseous atom to, to form its corresponding cation, and it is called ionization energy. Got it? So now we have A gas. It will give you 2 plus gas. It will give you 3 plus gas. Got it? So what I'm saying, I1, these are called successive ionization energies. Successive I1, I2, I3. So suppose if I'm taking this as sodium, suppose, the number of electron and proton will be 9, 8. So number of proton are fixed. Number of proton are fixed, right? And then we have number of electron. Then we have number of electron. Tell me. So in this case, 11 proton are attracting 8 electrons. In this case, 11 proton are attracting 11 electrons. So attraction will be maximum here. Similarly, I can say if I compare this and this, so 10 proton, sorry, 11 proton are attracting 10 electron. Here 11 proton are attracting 11 electron. Yes, we can remove, but to remove that electron, we need to provide very high amount of energy. Okay, Kyra. Yes, we can definitely remove, right? So when we will be removing it, we will be getting it. Got it? So successive ionization energies will keep on increasing, and this is always true. Note it down. Order of successive ionization energies will be this. Got it? Why? Because after removing one electron, number of electrons are decreasing. As a result, Z effective or net force of attraction will keep on increasing. Got it? Got it, guys? So let's move now. So what are the factors that affect ionization energy? What are the factors that affect ionization energy? So first of all, it is directly proportional to Z effective. Why? Because Z effective represent attraction. So if Z effective will increase, ionization energy will increase. So I will say inversely proportional to S. This is repulsion. And what do you mean by S? So S represent, yes, screening constant. Got it? Any doubt? So guys, more the repulsion. Suppose here we have proton, here we have electrons, right? And if repulsive forces are high, if repulsive forces are high, just a minute. If repulsive forces are high, what will happen? Then it will become easier to remove an electron. And in that case, we have to provide less energy. In that case, we have to provide less energy. Got it? So this is the cause of this. And now third point, the ionization energy is inversely proportional to size. Why? As size increases, the distance of nucleus from the outer electron increases and it becomes easy to remove it. Because now this is far away. To remove this electron will be difficult. It is very close to it. And you know the formula, right? So as this distance is increasing, distance between nucleus and proton, yes, to remove an electron will become easier. Got it? And next point is configuration. So what do you mean by configuration? Suppose I am taking nitrogen and I am taking oxygen. So in terms of Z effective, the configuration of nitrogen is 2p3 and it is 2p4. So this configuration is exactly half filled. And in this case, oxygen is having 4 electrons. 1, 2, 3. 1, 2, 3 and 4. Got it? So what I want to say here, yes, if I ask you that Z effective on O will be greater than Z effective on a nitrogen. Why? Because as we move from left to right, Z effective increases. But if I want to remove an electron from here and from here, it will be difficult to remove from nitrogen. Why? Why? Can you tell me, guys? Because in nitrogen, we have exactly half filled configuration. Got it? So next point, there is one more point that is left. Penetration effect. So the ionization energy also depend upon the penetration effect. So what do you mean by penetration effect? If you are removing an electron from 3s and 3p, so where you have to provide more energy? In case of 3s, right? In case of 3s, you have to provide more energy. Got it? So 3d. Why? Because of penetration effect. So now let's move. So what is the periodicity or what is the variation in a period? So when we move left to right, let me take one example over here. Suppose I am writing lithium, beryllium, boron, carbon, nitrogen, fluorine, right? So what is the configuration? It will be 2s1. Got it? Now if I ask you, in which case, in which case, when we move left to right, Z effective increases. As a result, attraction will increase. And if attraction increases, what will happen? Hi others, what will happen? It will difficult to remove an electron, so ionization energy will increase. Got it? I'm fine, I'm fine. So when we are moving left to right, when we are moving left to right, attraction is increasing. So in general, ionization energy should also increase, right? So now let's go into the micro details. I think sound is okay. Yes, can anybody confirm? Because sound is okay, I think. There should be no issues with the sound. So in this case, if we are removing electron, the electron is being removed from S and S. So ionization energy of beryllium will be more than the lithium. But if I compare Be and B, so what will happen? In case of beryllium and boron, in case of beryllium and boron, Z effective for boron will be more because boron is on the right. But in this case, tell me, in this case, electron is being removed from the P. Here it is removed from the S. So penetration effect of S is more. So in boron and beryllium, ionization energy for beryllium will be more. If I compare it, this will be more, this will be more. Again, here we have exception, not exception, now we have the logic. In this case, 2p is completely filled, here p is not completely filled. So this is more stable. If I want to remove an electron from this, it will be difficult. So I think now you got the answer. Where does those exceptions arise? Where does those exceptions arise? First point is this. Other than this, there is no other exception. So these kind of exceptions will always be there in all periods. Got it? Tell me if you still have any doubt. Note it down. Note it down, guys. Note it down. Any doubt, Abhidi, others, Kaira? Any doubt you have? So now you know the sequence and you know the regions also. You know the region also. Got it? So can you tell me? So this is the table which you can remember now. So in BE and B we have changed the position. In nitrogen and oxygen we have changed the position. Right? So the order is this way. You can remember it. You can easily remember it. If you want, you can take a screenshot of it, guys. Let me erase everything. Now you can take a screenshot of it. Variation of ionization energy. I've told you why there is exception here and here. Now they have followed it everywhere. Got it? Any doubt? Tell me if you still have any doubts. No doubt. So now let's move. If I ask you one question here, and what is that question? So just note it down. Yes. Tell me which one will be larger. You know that I1 of nitrogen is greater than I1 of oxygen. Why? Because it is 2p3 and it is 2p4. So it has become it is difficult to remove an electron from nitrogen because your nitrogen is exactly half filled. Now if I ask you I2, so what will happen? Can you tell me which one is more? I2 of oxygen or I2 of nitrogen? Tell me guys. Which one is more? So after removing one electron, this will become 2p3 and this will become 2p4. Sorry, 2p2. This will become 2p3. So what I'm saying here, this is 2p4, then it become 2p3. So we are comparing this data. In case of nitrogen, after removing one electron, I1, it become N plus. It is 2p2. Now if we want to remove one more, so this become N2 plus. So I will compare this with this. So in this case, this is exactly half filled. This is exactly half filled. So now can you tell me the answer? And if this is exactly half filled, so I will say that I2 will be greater than I2 of nitrogen. Got it? Got it? Any doubt? Any doubt, guys? Please ask me. Yes, others. So let me take one more question here. Now, if I talk about, yes, now answer me one more question. Yes, I1 of beryllium and I1 of boron, which one is larger? Can you tell me? Which one is larger? Be fast. You can write in the chat box. I1 of beryllium, I1 of boron. Which one is larger? So it will be beryllium. We have just done it because in beryllium we have to remove the electron from S and in boron we have to remove it from P. So the attraction in the S will be more. Attraction in the S will be more. Similarly, can you tell me I2 penne, which one is more? Yes, Asarani, if you are feeling that your material is not up to date, then you can get module or some reference material from any reputed institute. That is okay. These are good, but instead of books, you should go for the material from any institute. Don't go for the books, right? So just do it, guys. Now solve this one. If I'm comparing I2 of sodium and I2 of magnesium, what will be the answer? Can you tell me now? So in case of sodium, yes, Na2. So I will call it I1, I will call it I2. Okay, it's behind me. Can you see it now? So the configuration is neon 3s1, and now it become neon after removing one electron. So the next electron is removed is from neon, that is highly stable inert gas configuration. Similarly, if I compare it for the magnesium, it will be neon 3s2, it will be neon 3s1. So I have to compare this with this. So it is purely neon, it is neon 3s1. So it is easy to remove electron from here. So I2 of Na will be greater than I2 of magnesium. Got it? Yes, Asha, modules will be more than enough. If you are doing modules, then those are more than enough. Don't worry about that. Okay, got it? So now let's move. Now let's move. And similarly, if I talk about the ionization energy in a period, yes. So can you tell me the periodicity of ionization energy in a group? Yes, down the group, what will happen as we move down the group? Size increases, and if size increases, what will happen? The distance from nucleus increases, and if distance from nucleus increases, then it becomes easy to remove an electron. So what will be the order? What will be the order here? The order will be this. Got it? Any doubt? Please ask me if you have any doubts. Please ask me, guys, if you have any doubt. No doubt? Yes, Asha, actually in books, a lot of time is wasted. That's why I'm not suggesting you the books. Got it? So it should be the order. Now, if I compare it with the bangan aloo gajar in thali. So again, like we see in movies, the expectation. What should be the expectation? Yes, the expectation should be like it. B, then aluminium, gallium, indium, and thallium. But reality is different. Reality is different. So in reality, what is the order? Is there anyone who remember this order? Now I will tell you the order is, yes, actual order is B, and then we have Tl, then we have Ga, aluminium, and indium. So this is expectation and this is reality. You might have seen this in movies, right? So why this is so? Is there anyone who can explain me the fact why this is happening here? What is the reason behind it? Why this is happening? boron, thallium, gallium, aluminium, indium. Why at all? So now I will explain you that before gallium we have 3D, 4D, 5D, and before 5D here we have 4F as well. This is thallium, this is gallium. So what I want to say here, before gallium 10 electrons were added into the D, and these 10 electrons will have poor shielding effect. I told you, poor shielding effect. So due to that poor shielding effect, what will happen? These 10 electrons, suppose I'm making it, and now if I'm making the valence electron, right? So 10 electrons are added here, and repulsive effect, their repulsive effect is poor. And along with these 10 electrons, 10 protons were also added. So what will happen? These 10 protons will attract it strongly. This is attraction. As a result, as a result, what will happen? Yes, gallium and aluminium. Gallium will have larger force of attraction, and ionization energy of gallium will be greater than aluminium. You can compare. Gallium is more than aluminium. Now you know the reason, because of d electron. And due to same reason, why this thallium jumped to second position from here to here. What is the reason? So before thallium, we have 10 electrons are added in the D, 14 electrons are added in the F. So along with these, 24 proton will also be added, and those 24 proton will attract the outer electron with very strong force, but their repulsion is poor. So net attraction on it will be increased. As a result, it will become very difficult to remove an electron. If you remember, today I also told you the inert pair effect. Yes, that is also caused due to poor shielding effect of this. 14 F electrons and 10 D electrons. Got it, guys? Got it? Any doubt? Any doubt you have? Tell me. So now let's do this. So this is expectation. Let me change the color. So this is expectation, right? But this is reality. So what is going on? Helium is going here, then helium and gallium, then indium. Now you know the reason. So let's move. Again, I'm showing you in the table. Before this gallium, we have 10d electron, and before this thallium, here 57 and 72. So we have 14f electron, and then we have 10d electrons. So due to this, it will reach to this point. Got it? So net force of attraction will be very high. Any doubt if you have, please ask me. Please ask me, guys, if you have any doubt. No doubt now? Done? Can you tell me for D block? Let's compare it now. Yes. For D block, we have following transition series. Here we have S block, here we have P block, right? Actually, in D block, as I have already discussed, no property is properly followed. This is S, this is P block. Got it? Now tell me. Now you know the S block, now you know the P block. Yes. So what I'm telling you here, this is 3D, 4D and 5D. So in 5D, they start with scandium, yttrium and lanthanum. And now let me tell you, no particular order is followed, but ionization energy of 3D and 4D is approximately same. But ionization energy of 5D is greater than 4D. Why? Can you explain? Actually, down the group size increases, so ionization energy should decrease. But ionization energy of 5D is greater than 4D. Can you tell me why this is? Anyone? Can you guys tell me why this is so? Anyone? Now I will explain you. Yes, just look at it. So this is the 5D and these are the 4D, right? Just look at it, it is 57 and this one is 72. So one we have 57, another we have 72. So why I am telling you this? 57, 72. In between them we have 14F element. In between we have 14F element. And these 14 elements F electrons have very poor shielding effect. Now D also having very poor shielding effect. So due to that poor shielding effect, net force of attraction will be increased. As a result, these will experience lanthanoid contraction. Their size will also shrink and ionization energy will increase. Do you remember it? Ionization energy will increase. So this is followed here. Got it? So this is the reason why ionization energy increases. So let's move now. If I talk about ionization potential. So what is ionization potential? So if ionization energy is if ionization energy is 10 electron volt, so ionization potential will be 10 volt. Because how do you calculate the potential energy? How do you calculate the energy? Q into V. So charge on electron is E, and if you place it in 10 volts, so its energy will become 10 electron. So basically ionization energy and ionization potential have different units and they are different. But if I'm saying ionization energy is 20 electron volts, so ionization potential will be 20 volt. At many places they are used synonymously, but strictly speaking they are different. Strictly speaking they are different. Got it? Any doubt you have? No doubts. So now you know the ionization energy. Let's move. So what do you mean by low ionization energy? Suppose A and we have B. Suppose its ionization energy is 10 electron volt. Its ionization energy is 5 electron. So here I have to provide low ionization energy. And I can say this electron can be easily lost. So if this electron can be easily lost, What does it mean? What does it mean? Tell me. So low ionization energy means electron can be easily loose. It means B is more metallic. Because what is metallic character here? So metallic character means tendency to lose electrons. if if something can lose electron easily, I will say that is more metallic. And if it is losing electron, oxidation of this is taking place. So I will say it is having better reducing power, or it is a better reducing agent. So lower ionization energy means more metallic character and better reducing power. So if someone asks you A and B, ionization energy is 10 and 20, which is better reducing agent? Can you tell me the better reducing agent? Which will be the better reducing agent? Tell me. So is it A or B? Is it A or B? A. Which is more metallic? A. Which is more reactive? A. I hope now you got it. So if some atom loses electron easily, I will say it is more reactive, right? I will say it is more reactive. Low ionization energy means electronegativity will be less, which we will be studying in the next class. And remember it, this problem was asked in September 2020. So if ionization energy data is given, using that data you can tell me about the oxidation state, which oxidation state is more stable. Suppose the difference between I2 and I1 is greater than 16 electron volts. So I will say that plus 1 oxidation state is stable. If it is less than 11 electron volt, then I will say plus 2 oxidation state is stable. Got it? So if you are provided ionization energy data, then you can find it. Any doubt till this point? So with the help of ionization energy data, you can also find out the valence. How? Suppose, suppose you are given I1, I2, I3, I4, I5, 4A. Suppose you are given data 10, 20, 30, 300, 400. So can you tell me the number of valence electron here? Number of valence electron. Can you tell me? And how will you find that valence electron? What is the exact way to calculate the valence electron? Can you tell me? So now I will take it up. Just look at this data. Here we have a jump. It means I can say after losing 3 electrons, I have to provide a very large amount of energy. It means there were 3 valence electrons. So you should look for this jump in terms of percentage, not in terms of amount. Got it? Let me take next case. Yes, how many valence electrons are possible in this? So just look for the jump. Where there is a jump, this is after losing one electron, two, three, four. Where is the jump? Tell me, where is the jump? So the jump is here. It means I can say after losing four electrons, it becomes very difficult to remove the fifth one. It means the valence electron will be 4. Now let me take one more example. Yes. Can you tell me the valence electron for this scenario? For C? Anyone, anyone. Can you guys tell me the valence electron for C? Be fast. No answers? Tell me fast. If you look for the jump from 20 to directly 300, and then we have 400, 600. In terms of percentage, this is the jump. More than 10 times, right? So now I will say it is having valence electron of 1 only. So if ionization energy data is given, then using that ionization energy data, you can find out valence electron. You can find out valence electron. Got it? So now let's move to the electron gain enthalpy. What is electron gain enthalpy? What is electron gain enthalpy? If I talk about electron gain enthalpy, this is a gas, and one electron is added and it is converted into a gas. So when an electron is added, generally, not always, generally, energy is being released. Suppose it is 100 kilojoule, right? So I will say this is electron gain enthalpy. So when an isolated gaseous atom absorb an electron, energy is being released in general, not always. And this energy released is called electron gain enthalpy, right? So suppose for B gas, we have electron gain enthalpy of minus 200. For C gas, we have electron gain enthalpy of minus 300 kilojoule. Why I am writing it? So because now I'm going to define another term that we call electron affinity. So electron affinity is equal to minus of delta EGH. So if I calculate the electron affinity, it will be 100, 200, 300. So what do you mean by affinity? Affinity means attraction, attraction, or affinity means love. So electron affinity means love for or affinity for electron. So electron affinity is maximum for this case and minimum for this case. So electron affinity order will be C, then we have B, then we have A. Got it? Electron affinity order will be this. Any doubt? So electron affinity is equal to minus delta E. So it represents tendency to gain electron. Higher the value of electron affinity, higher will be the tendency to gain electron. Got it? Any doubt? Any doubt? No doubt now? Tell me if you have any. So what is second electron gain enthalpy? Now let's discuss this. If I'm adding one electron, so this is called first electron gain enthalpy. Suppose this is minus 100 kilojoule. So energy is being released. So A minus is more stable. Now if I'm adding one more electron, it will give me A2 minus gas. So the electron gain enthalpy in this case will be positive. And why this is positive? Can you tell me? Why this is positive? Now I will tell you. This negative, there will be repulsion, right? So they will not be, or electron will not be gained automatically. In that case, what we have to do? In this case, हमें जबरदस्ती करनी पड़ेगी. We have to forcibly add. So we have to provide the energy. So we call it second electron gain enthalpy. So note it down. Second electron gain enthalpy delta Eg2 will always be positive. Second electron gain enthalpy will be always positive. Got it? Second electron gain enthalpy will always be positive. Note it down. Note it down. If you have any doubt, please ask me. Then what are the factors that affect the electron and electron affinity? It is directly proportional to Z effect. More the Z effective, more will be the attraction. It is inversely proportional to screening constant because it represents repulsion. Higher the repulsion, less will be the electron affinity. And electron affinity is inversely proportional to size. More the size, low will be the tendency to gain electron. Got it? Less will be the tendency to gain electron. I hope now you got it. Tell me now. Any doubt? Then again, exactly half filled or full filled. If I talk about an endo, so 2p3, 2p4. If you add one electron, this is stable. It does not want to add one more electron. It can add. So if your electrons or if your element is having exactly half filled or exactly fulfilled configuration, then it is not going to gain electron. Then it is not going to gain electron, right? So in that case, electron affinity will be negative or zero. So for noble gases, helium, neon, argon, we take electron affinity to be zero. Got it? Because they never gain electron. And if electron is added in S, P, D, and F, so in S we have maximum attraction. So maximum energy will be released. So I will say the affinity will be more if electron is added to S as compared to the P, right? So this will be the electron affinity order. And if I discuss the factors affecting electron affinity, that is done. So the relationship between electron gain enthalpy and I1. So let's do it. Plus one electron. So this, this is delta H plus 100 kilojoule per mole. I will call it ionization energy 1. So if I write it in the reverse, this is electron gain enthalpy of A plus, not A. So it will be minus 100. Why I am telling you this? So I can say magnitude of electron gain enthalpy of A plus will be equal to ionization energy of A. Their magnitude will be same. Note it down, guys. Their magnitude will be same. Any doubt? No doubt. Let's move now. So S and P, when we move left to right, Z effective increases, and if Z effective increases, electron affinity also. When we move top to bottom, Z effective decreases or remain constant, the electron affinity will decrease. So it is general trend, right? H is enthalpy. So now I will tell you, lithium on gaining one electron, electron gain enthalpy will be negative, electron affinity will be positive. So not just lithium, ns1 plus one electron will become -2. Got it? And in this case, electron gain enthalpy will be negative and electron affinity will be positive. So we call them metals, and generally metals have tendency to lose electron, right? But in this case, if you observe it, if you observe it, you can see even metals, when they gain electron, energy is released and their electron affinity is positive. If I talk about this, here we have problem. Why? In this case, general configuration is ns2. On gaining one, it will become np1. So it is already completely filled and it does not want to gain it. So electron gain enthalpy will be positive and electron affinity will be negative. And negative means they don't want to gain electron. Negative means they don't want to gain electrons. And if they don't want to gain electron, so their electron affinity is negative. So what are the elements which are having a negative electron gain enthalpy? Now I will show you in the periodic table. This NP6, nitrogen and these. So second group, 18th group, zinc, cadmium, mercury and HF and nitrogen. These have electron affinity 0. Rest all have positive electron affinity. It means whenever they will gain electron, some energy will be released. It means whenever they will gain electrons, energy will be released. Got it? Any doubt? Now tell me guys if you have any doubt. Be fast. No doubts now? Just remember it, it will help you in the exam. That's important. That's important. There is one more point that is important here. In groups, down the group electron affinity what? Decreases. But in second period, aluminium, silicon, chlorine. So electron affinity of chlorine is greater than this. Silicon is greater. So third period elements for P block have more electron affinity than second period elements. Got it? Third period elements will have more electron affinity than second period elements. Any doubt? Remember it. So in periodic table, chlorine is having highest electron affinity. Note it down. Chlorine is having highest electron affinity. Remember it. What is the reason for it? What is the reason for it? Now I will tell you. If electron is added to the second shell, then second shell is having small size, and due to small size, repulsion will become more. But on third period, they have vacant 3D orbitals. They have vacant 3D orbitals. So if extra electron is added to them, yes, they can delocalize or they can shift their electron in the vacant d orbital. Got it? Any doubt? So phosphorus and onward electron is added to the third shell where they have vacant p orbital. So find the least and the maximum electron affinity. How will you arrange it? Just write. Just write. How will you arrange it? Be fast. So the best way to solve such problem is just arrange them as they are arranged in the periodic table. What is that way? Chlorine, chlorine, oxygen, sulfur. So this will be the order. So the maximum is chlorine, minimum is, yes, tell me, oxygen. I hope now you got your answer. Is minimum because we just completed it. In a period it increases. Nitrogen is having almost zero. Got it? So just do it. The first ionization enthalpy of nitrogen and oxygen are respectively. What will be the answer? Tell me. The first ionization enthalpy of nitrogen and oxygen are, so nitrogen and oxygen. So ionization enthalpy of nitrogen will be more due to exactly half filled. So first option, it will be more and less. The answer will be A. So you don't have to remember these values, guys. You don't have to remember it. You just can check. This is more, this is less, and there is only one option. So let's do now the next problem. The first ionization enthalpy of Na, Mg, aluminum and silicon are in order. So I just told you how you can solve it. Na, so what will be the order? Magnesium will have 0 or least, and then it increases from left to right. So how will you answer it? Just look where the magnesium is having least value, silicon is having maximum. In silicon and aluminum, silicon, then we have aluminum, and then what is this? So how will you answer it? This will have more than this. So silicon, aluminum, What will be the answer? Tell me. What will be the answer? Any guess? So magnesium belongs to second period that will be having least. So this cannot be your answer. This cannot be your answer. Yes. So actually there is no answer which is given in the options. So now I will tell you Na, Mg, aluminum and silicon. Yes. Order will be this. Just note it down. Got it? Now let's do this one. Which represent the alkali metals? So alkali metals is having configuration NS1. So there should be a jump in first and second. It is 2 times, more than 2 times, 15 times. So C will be your answer. Got it? Because there is a jump. We discussed this concept today. So guys, you can try these problems at your home. You can take a screenshot of these, right? So this is all for today, and I hope you enjoyed today's class. Just click on the bell icon so that you can get latest notification of our lectures, and like it and share it. Don't forget to like and share it. And just now I will tell you the simple step. Download the Unacademy's learning app, install it, and after installing it, click on the plus, choose IIT JEE as your goal, then hit the subscription button. Once you are hitting it, yes, apply my code, that is Rahul Game. If you are applying this code Rahul Game, then for 1 year the fee will be 34,000. For 2 years fee will be 50,000 instead of 56,000. So guys, just remember this code, and if you are applying this code, then you will be getting this discount. So this is all for today, guys. Thank you. Bye bye. Take care of you. I'll meet you again.